Assalamualaikum warahmatullahi wabarakatuh, and hi everyone. Welcome back to discussion on example for soil strength topic. This is the second part. So in this video we are going to discuss on some examples related to determinations of shear strength parameters based on some testings. So in this video we are going to discuss the example related to unconfined compressive strength test, direct shear test, and also triaxial test, in which that it will also covers on unconsolidated undrained, consolidated undrained, and consolidated drain test respectively. So let's look at the first example. Okay, the data given in this slide is the example from unconsolidated undrained test. Okay, so let's look at the questions. Okay, this table tabulated informations for 3 specimens is identical specimens subjected to different minor principal stress, also known as confining pressure. So for sample 1, sigma 3 given is, so this is sigma 3, okay? The minor principal stress is known as sigma 3, and the deviated stress here is a surcharge, okay? Or loads provided to each specimen. So we have sample 1, or specimen number 1, the minor principal stress is 69, sample 2, 136, and sample 3 is 207 kilonewton per meter square, or kPa, kilopascal. And deviated stress is given for each of them. So the question asks you to find or to plot the Mohs circles, okay, the Mohs circle for each specimens, and determine the shear strength parameter. So first of all, you have to know that this is unconsolidated undrained test. So for unconsolidated undrained test, in which that during consolidations the drainage valve is closed, so water is not allowed to dissipate away from the specimen. Similarly for the second stage, okay, the loading is applied to the specimens in undrained conditions, in which that still the drainage valve is closed. So therefore there is no change in volume, in which that the circles, okay, corresponding to each specimen will have the same size, okay, where in the end of that the failure line would be horizontally to your x-axis. Okay, all right, so we already have 2 sets of informations here, which is sigma 3 and sigma d. So what you can do now is to calculate sigma 1. Okay, sigma 1 is equal to sigma 3 plus with deviated stress at failure, which is the information is given here. So you can have another columns here to find out what are the sigma 1. Okay, is the value of total up between sigma 3 plus with deviated stress. You have sigma 1 there. Alright, here is the complete information of major principal stress and also minor principal stress. Okay, major principal stress is already calculated by adding these 2 informations, these 2 parameters. So 345 for specimen number 1, 462 for specimen number 2, and 566 kilonewton per meter square for specimen number 3. So once you have both principal stress, minor and major, you can plot the Mohs circle. So this is the Mohs circle for sample 1, this is Mohs circle for sample 2, and this one is a Mohs circle for sample 3, where they will provide the failure lines that parallel to the x-axis. Okay, noted that y-axis is your shear stress, and also the normal stress is x-axis, and noted here also that the scale for both axes are same. Okay, back to the questions. Okay, the question asks you to plot the Mohs circles. Okay, so you already done this, and find the shear strength parameters. So for u, okay, the shear strength parameters are only given by the C value here. So it seems like the C value is equal to around, I think, 150 plus. Okay. Okay, now let's move to example 2. So for example 2, the question is related to consolidated undrained test. So remember, when it comes to consolidated undrained, which is CU or CU test, so the first stage, okay, during consolidations, the drainage valve is open, so the water is allowed to drain out from the spacement. Therefore, the spacement is been consolidated, so it comes C here. And during the second stage, okay, the loading is applied in undrained condition where the drainage valve is closed. Okay, so therefore, okay, in this stage, which is the second stage, the water is not allowed to be drained out. Those will have some changes on the water pressure at failure. Okay, it's either increase or decrease. Okay, so by looking this table, okay, you will see that there's a 4 informations given here. The self pressure, okay, for 3 spacements. Okay, we have the 3 spacements here subjected to different confining pressure, 200, 400 and 800. So the self pressure here is your minor principal stress value, which is sigma 3, and the deviated stress at failure is given by the information in the second column, okay, for each of the spacements 117, 242 and 468, and the major principal stress here, okay, for each of them, sample 1, 2 and 3 is 317, 642 and 1268, and the unit is still in kilonewton per meter square. So the major principal stress here is sigma 1. Okay, and because this is CU test, okay, it is CU test, so there is a water pressure developed during the second stage, okay, during loading, where spacement number 1, the water pressure or the U value is equal to 110, 227 for spacement number 2 and 455 for spacement number 3. So the question asks you to find the shear strength parameters of the soil for 2 different states, okay, in which that the first one is total stress and the second one is effective stress. Okay, remember, for CU test, okay, the shear strength parameters can be determined by these 2 states. Okay, we have a total stress and also effective stress. Okay, so when it comes to total stress, okay, the information is all here. Okay, you have sigma 3 and sigma 1. So you can easily plot the circles. But when it comes to effective stress, okay, remember, for effective stress, it means that if this is your total stress, okay, so for effective stress, okay, which is sigma prime, the total stress, okay, have to minus with the water pressure. So whatever value from cell pressure and major principal stress here, you have to first minus with the U value here for each of them to find out what are sigma 3 prime and also sigma 1 prime. Okay, so let's look at the solutions. So this table is already provide with all the information necessary, okay, for you to plot the Mohs circle with regards to total stress and effective stress. So I already calculated for you the effective stress for major principal stress, sigma 1 prime, and also minor principal stress in effective stress condition, which is sigma 3 prime. So the information is already given here. Therefore, what you need now is, okay, to plot the Mohs circle for total stress, okay, you need the informations here and here, okay, for sigma 3 in total stress and sigma 1 for total stress. And for effective stress, now you need the informations here and here, okay, for sigma 1 prime and also sigma 3 prime. Okay, so this is for effective stress and this is for total stress, these 2 informations. Then you can plot the Mohs circles, okay, with provide the scale first, okay, for x-axis and also y-axis, and plot first the total stress most circle. This is for specimen number 1, specimens number 2, specimens number 3. Okay, and what you need to do now, remember, even though you prepare an identical specimens, but since the states of analysis is different, one is total stress, one is effective stress, so they are not going to share the failure plane or the failure line. So they will have their own failure line, which in the end they will also have different shear strength parameters. So this is the failure line for total stress. Okay, this is for total stress. So from here you find out that the C value for total stress, or normally for CU we put it C sub CU 10 kPa, and the friction angle given is 11.3 degree. Okay, this is for total stress. Now plot for effective stress. So you have 3 circles represent effective stress circle, and by plotting the failure line here, you find out that C prime, okay, is 12.5, and the friction angle, okay, I forgot to put, this is supposedly 5 prime, okay, 5 prime is 23 degree. So that are the answers for both sets. Okay, this is for this 2 is for total stress, and this 2 is for effective stress shear strength parameters. Okay, this is the example for CD test. So CD, it means that C, it means that the sample is being consolidated, the drainage valve is open during the consolidation stage, and D means that the shearing or the loading applied in drain where the drainage valve is still kept open during second stage. Okay, so it means that the water pressure at failure will be equal to 0 because there is no yes, there is a dissipation of water pressure during the second stage, which means that change of water pressure will be equal to 0. So from the table given here, there's only 2 informations for 2 specimens, identical specimens here, symmetry and deviated stress. So you can straight away calculate sigma 1, okay, equal to sigma 3 plus deviated stress at failure. So sigma 3 plus deviated stress at failure, this one is 220, 80 plus 140, and 170 plus 225 is 395. Alright, so 2 principal stress are been calculated here. So you already given sigma 3 and you already calculated sigma 1. So the next step is to plot the Mohr circle. Okay, so to plot a Mohr circles, okay, I just do it roughly. Okay, so let's say this is the Mohr circle for specimen number 1, 220, and where sigma 3 is 80 and sigma 1 is 220 for specimen number 1, and specimen number 2 is 170. Let's say here is 170, and 395 is, yeah, maybe here. Okay, so you have another circles, okay, for specimen number 2. Okay, therefore you can plot the failure line here, okay, tangent to both circles because you only have 2 circles, so definitely it has to be tangent to both of them. So from here to here is your C value, okay, because it is CD, so normally we put C sub CD, or you can just put C, and the slope for the failure line, this is your friction angle. Okay, all right, so you can try to calculate it by yourself, do it by yourself later. I'll just shows you how to do it, how to solve it. And another thing that you need to know is for CD test, the total stress parameters will be equal to effective stress parameters, because total stress, okay, to get the effective stress equal to total stress minus water pressure, right? So there is no water pressure, okay, in the end of the testings, which is equal to 0 here. So the total stress would be equal to effective stress. So whatever the shear strength parameters, okay, C and phi here, or C and phi here are same. Okay, now move to the last example, which is example number 4. So this is the example related to direct shear test. And the table given here are the informations of sample tested on dense sandy clay under direct shear test. So we have 3 specimens here subjected to different normal load, 25, 40 and 50 kilogram. And the strain at failure provided here is specifically or related to the shear force value, okay, in which that when you have a strain at failure, it means that you need to calculate the cross-section area changes. So you need to have the change in cross-section area. But to get the change in cross-section area, first you need to find out what are the initial cross-sections. So there's information here on the dimensions or the size of sample, which is 60 times 60 millimeter, with the sample thickness is 25 mm. So nothing to do with the thickness, you just need the dimensions here. The cross-section area 60 and 60, convert to meter, so it will be 0.06 times 0.06. Therefore, the initial cross-section area would be 0.06 times with 0.06, so it equal to 0.0036 meters square. So I convert the units to meter. And the strain at failure here, okay, there is information as strain at failure here. You need to find what are the change in cross-section area, which is equal to initial area divided by 1 minus strain. So you need to first convert the value of strain here in decimal point. So 5.5 divided by 100, so it will be 0.05. Okay, so calculate what are the change of cross-section area subjected to the strain at failure here. So it will be, for example, number 1, 0.036, which is the initial cross-section area divided by 1 minus 0.055, and the same thing also for second sample. Only change the value of strain at failure here. So after calculated the value, I found out that the cross-section area for the first sample would be 0.00381. Okay, for sample 2 is 0.00379, and the last one is 0.00375. So you have another information there. Okay, now you can calculate the normal force and shear force. Okay, remember when you carry out direct shear test, you will need 2 data, okay, being analyzed from the raw data that given in this table. You need to have normal force, okay, and shear force, okay, a set of normal force and shear force. So to find out what are the normal force is normal stress and shear stress. To get the normal stress is equal to normal force divided by area, and to get the shear stress is shear force divided by cross-section area. So here are the initial cross-section area. For normal stress, shear stress is the cross-section area corresponding to changes, okay, subjected to the strain at failure here. So first calculate the normal force, okay, but be careful that normal force is in normal stress in Newton per meter square. So you need to convert first, okay, the normal load here to kilonewtons, okay. So you need to change it to kilonewton. So once you already change, okay, I found out that 25 kg is equal to 0.25 kilonewton. 40 kg is equal to 0.392 kilonewton, and 50 kg is equal to 0.490. Okay, it's about that, the value. Okay, you need to convert first, okay, because value here, you have to divide with initial cross-section area for normal force. Okay, for normal force, there is no distortion happens. It's only quantify change in volume, so there is no change in shape. It's only change in volume. So the cross-section area changes here is subjected to the second stage, which is when you apply the shear force. The first stage still using the initial area. So whatever value here, 0.25, 45, 0.392 and 0.490, divide by 0.0036, then you get the value of normal stress. So from the calculations, normal stress is equal to, here is 68, sample 2 is 109, and sample 3 is 53. Okay, so you already have the normal stress, okay, in kilopascal or kilonewton per meter square. So now find the shear stress, okay, which is the same unit, kilonewton per meter square or kilopascal. So for the shear stress, okay, the ultimate force here, okay, you have to divide by whatever change in cross-section area, yeah, respectively. But since we want to make sure that the unit is consistent, kilonewton per meter square, but here is in Newton, so you need to convert to kilonewton first. So this would be 0.125. You just divide by 1000, Newton to kilonewton, and this one would be 0.165 kilonewtons and 0.2 kilonewton. Divide by whatever change in cross-section area here. Okay, after the calculations, I found that the shear stress at failure will be equal to about 33 for sample 1, 44 for sample 2, and 53 for sample 3. Okay, so now you already have those two important informations, which is normal stress and shear stress. So the next steps is what you need to do is just plotting the informations in graph. Okay, you plot graph. Okay, for example, like this is your graph. Okay, so this is your shear stress and this is your normal stress. So whatever informations here, okay, and here, just translate to this graph. So let's say the first point is here, okay, the second point is here, the third point is here. So you have 3 points, so you need to get the best fit line. Okay, it means that not necessary to connect each point, but if you can connect each point, then it's okay. But if you unable to connect each point, means that the failure line would be a best fit line. Okay, so let's say this is your best fit line, so this is your C value, and the slope here are friction angle failure. Okay, so that's it for example with regards to direct shear test. Okay, so we already finished discuss some examples related to determinations of shear strength parameters based on different testing. Test on triaxial test for UU, CU, and CD, and another one is for direct shear test. For UCS test, I think is quite similar, almost similar to UU test, and it's quite straightforward as well. So you can easily find any examples, okay, in different sources. But what I hope that whatever that has been discussed in this video are helpful and useful for you, which can add your understanding on this topic. With that, thank you very much. Assalamualaikum.